All right, hey ladies and gentlemen, so we are going to talk about kind of graphing radical functions, but using shifting, the idea of shifting, kind of like our vertex form. So I want you to check out our overall parent function of the radical. Okay, so we've talked about this, y equals the square root of x. Okay, so that's the basic function. Instead of using decimals or anything like that, I'm going to put in some nice numbers because we're talking about square roots. So the square root of 0 is 0. What's the next perfect square we know? Well, 1, the square root of 1 is 1. Okay, next perfect square up is 4 because the square root of 4 is 2. So that's kind of the basic parent function. It's going to look something like this. 1, 2, 3, 4. 1, 2. So at 0, it's at 0. 1 is 1. And then over here at 4, it's at 2. So it kind of curves through like that. Okay? We are going to talk about shifting. So in vertex form, so the standard form of a radical is y equals a times the square root of x minus h plus k. Okay, so as you can guess, each of these things do something. A makes it wide or narrow, like skinny or fat. Also open up or down. Oops, there's down. And I'll talk about that more, opening up or down. H, okay, so the H, comma, K is the starting point. Okay, so that's what we're using, and we're kind of figuring it out, like that's where it shifts, left or right. Okay, so know that this is kind of what we are stemming from when we go to the next page. Okay, so again, I'm just going to kind of write that y equals the square root of x. So we know we've got x, y, 0, 0, 1, 1, and 4, 2. Okay, so when we look at other examples, and we've got like y equals the square root of x plus 2 plus 4. Okay, so recognizing how this is changing. So it starts at, instead of 0, 0, it's starting at negative 2, comma 4. Okay, so what does that mean? It means it goes left 2 and up 4. So every single one of these x's is going to be to the left 2, or 2 less. So instead of having these values, 0, 0, I'm going to have negative 2. Instead of having 1, subtract 2, and I've got negative 1. Instead of having 4 minus 2, I've got 2. Okay, so these values here are all to the left of these values. Okay, and instead of having 0, 1, and 2, I'm going to have 4 more than that. 4, 5, and 6. So from that basic equation that I had, that parent function, 1, 2, 1, 1, 2, 3, 4, 5, 6. Okay, so this one starts at negative 2, 4, 5, and then all the way over here at 2, we're at 6. So it's the same shape, but shifted left 2 and up 4. Okay, another one. So let's say we have y equals 3 times the square root of x. Okay, well that a tells us it's still opening up, But, actually, let's make it -3 times the square root of x. Okay, but everything is going to be multiplied. Like these values that we had here are going to be multiplied by -3. So we're not changing it left or right. We're still going to use 1, 0, 1, and 4. But instead, the y values, the outputs, are going to be multiplied by -3. 0, -3, and 6 times -3. Or 2 times -3 is -6. Okay, so it's going to open down. One, 2, 3, 4, 5, 6. So 0 is at 0. 1 is at -3. And 4 is way down here at -6. So it's definitely a wider curve than what we had, okay? So taking a look at that and seeing the shift that happens. It opened down. We've only still got that one arrow on there. Okay, so here's what I want you to do. I want you to look at the following equations. Oops. And I want you to tell me just how they are changing, okay? How do they change? Like left 2 or right 2 or whatever it is. Y equals negative square root of x minus 1 plus 3. Y equals the square root of x plus 4 minus 1. And y equals 1/2 square root of x plus 5. Okay, just tell me how that shifts from the parent function, what changes happen. Okay, have a super night. We will see you tomorrow.